So I'm Pradeep Vincent, again, one of the architects with the Oracle Cloud Infrastructure team. I'm primarily going to share some of the architectural aspects of infrastructure cloud, but I think it's mostly going to be a whiteboard session with Q&A, so I think I'm going to let you guys drive. But I think, before we do that, I wanted to have a quick recap of essentially a gist of what Leo introduced. Some of the key goals and visions around how we approach the cloud platform, and how, from an architectural standpoint, we made a bunch of decisions in the last 3 years, and how that enables some of these visions and goals. Right. So not to say the same thing, but as Leo pointed out, this is one of our key goals, right? I don't want to go into more details. I'm sure everyone already has this. The goal here is essentially to replace, help enterprise customers run pretty much anything they run today in their on-prem data center in the cloud, and that could be VMs or bare metal or file system or block storage or databases or load balancers or higher level software stacks, whatever it is. We want them to be able to have the similar experience over here as well. And the second goal we have is that we want to meet enterprise requirements, right? And what this means will change over time. But let's, just to give some perspective, couple of key examples. So one of the recent examples we did, we launched the SLAs recently. Couple of them are industry first, and particularly the one that I'm very much related to, I work on, is the performance-related SLA. The other thing that we strive towards is essentially, not to use the same term enterprise lift and shift, but essentially if you think about how do enterprise customers bring their workload without too much changes? It may require some changes, and then bring it over to the cloud and make some small changes. And what does that mean? So it means a variety of things for different customers. It may mean old operating system support or support of bare metal and VMs. It may mean bringing their databases or database configurations over. It may mean network configurations or traditional network configuration with IP failover, things like that. So our goal is essentially to enable most of them. Now with that, let's go into see why the way we look at architecture and how that helps us achieve those goals. So, 3 years back when we started the initiative, we launched the product 1.5 years back. 3 years back when we started the initiative, we took a step back and looked at the requirements and what's out there in the industry, and what do competitors have. And we really wanted to architect an enterprise-focused cloud. So we came up with a bunch of tenets and goals around architecture that not only served short-term product goals, but also laid the foundation for the long-term goals as well. And let me cover a few of these key aspects. So, at the foundation of it, we wanted to lay down the key constructs of infrastructure cloud. So we have the notion of a region. A region is essentially, a cluster of data centers in a geolocation. Within a region, we have, availability domains. And availability domain is essentially 1 or 2 data centers that are very tightly knit together. And within that, we have extremely high, low latency and high performance networking across them. The way we think about the availability domains is that, well, looks like some of the slide decks changed. Is that correct? All right, cool. All right, cool. So the way to think about availability domains is that we have some hard constraints on what availability domain is and what a region is. In particular, our goal is that For the way we define a region is that it has a bunch of availability domains. Those availability domains need to be far enough apart, both physically as well as from a networking and a power supply perspective. But at the same time, it needs to be close enough so that it actually allows synchronous data replication. So the goal here is essentially to have a foundational aspect using which software stack, both our own software stack as well as customer software stack, can achieve high availability and durability.
Pradeep, synchronous replication can be done over any distance. It just means that the latency will be awful the further you go away. So there must be a latency goal within that synchronous replication that you're looking to achieve.
Yes, absolutely. So we have, as an example, within a region, the rough estimate that we target for is like 1 millisecond, right? So within those boundaries, today we are actually at half a millisecond in many regions, but that's not to say our goal is essentially to limit ourselves to 1 millisecond. So if let's say we need to launch new availability domain in Phoenix, which is one of our regions we have today, we will pick locations so that the diameter allows us to give 1 millisecond latency to the customer.
What does that translate to as far as maximum distance, maximum separation?
It's a few kilometers at the moment.
No, it actually translates to like 60, 70 kilometers.
Okay.
But within our availability domain, that number is actually close to true. So within our availability domain, we want to give extremely aggressive latency, and for that, we essentially limit ourselves to like few kilometers. Right? And in many cases, our available domain is just one data center right now, which is obviously extremely good latency. Right? Apart from latency, availability domain is also about bandwidth. So we have, on top of this, let me come back to this. Let me actually control this from here. So on top of availability domain, we have physical network infrastructure. One of our goals for physical network is that within our availability domain, we want to have a non-oversubscribed network, right? So even though the latency is one of the goals, the second goal is essentially network throughput. Right? So what that means is that within a data center, your storage and a compute can be in literally any place. It doesn't matter. They should be able to talk to each other and do replication, whatever it is, right? And I think from one of our key goals was essentially. Let me actually forward this a little bit more. All right, so the network SLA that we recently launched was essentially based on this. So if you think about network performance, I'm pretty sure the class network is all the rage these days. Everyone has that. It's pretty standard in the cloud world. Amazon has it. Microsoft has it. But it's not just about a network topology. It's also about a policy on how much oversubscription we want to do inside the network. So in our network, we make a deliberate policy decision to say, hey, we will not oversubscribe within a data center. Right? It has certain business implications, cost implications, but we fundamentally believe for enterprise workloads where we want to have strong performance guarantees that we can give to the customer, we really wanted that. So we made the decision 3 years back that that's one of the criteria we're going to have, and that essentially allowed us to do network SLAs, which we recently launched. Well, so going back, so we have availability domains, we have physical network. On top of it, we have a virtual network. Virtual network is essentially a customer-facing network, and this essentially plays a key component for the whole notion of run the entire business. So the OCI cloud platform is designed to be the common network fabric for all Oracle cloud services, right? So whether you have compute or storage, database, network, or in the future, SaaS applications, they all plug into this common virtual network that customers control. So what that means is that it actually starts looking very similar to your on-prem network, where it's like a private network, and your VMs and bare metal nodes, they can talk to your SaaS applications through that without going through the internet or any of that. Now, beyond the availability domain, a physical network, and virtual network, we also have all right. So we also made some architectural decisions on the compute itself. One of the things we decided early on was we wanted to offer customer a bare metal compute product itself. What that means is that it doesn't have any hypervisor, and when we launched, we were like the first in the industry to do that. One of the main reasons we wanted to do that was enable customers to bring their own workloads, whether it's their own hypervisor or as a bare metal workload, onto the cloud without having to make a lot of changes. And one of the key challenges there is around how do we actually do virtualization, whether it's network virtualization or storage virtualization. Where do we actually do it? So we actually, right from the scratch, we had to do virtualization outside the box. So we essentially architected what we call as off-box virtualization mechanism outside of the physical servers itself, and that's essentially where most of our secret sauce essentially lives.
What is all the hardware that runs this? Is it your own? Is it?
Yeah, it's a proprietary logic that's essentially
The logic, that sounds like software. What about the hardware?
You mean is it? What do you mean
The
hardware?
underlying hardware that's running this. Who are you using for all this?
So we have a fairly vendor neutral approach in terms of underlying hardware. We can talk offline about some of them. One of the goals is essentially to have from a supply chain, it's not so much architectural perspective, but from a supply chain perspective, we want to have multiple options. So we do have an architecture that allows us to replace that, if you will, when need.
That off-box virtualization piece, does that mean you are running your own custom network operating system on commodity switches or something similar?
We use a heavily customized mechanism. We do some customization. We also work with external vendors on that.
So this non-blocking network, so I think one of the tough things that I'm trying to wrap my head around is that from a engineering, no one guarantees outside of you guys a non-blocking network. When I go to AWS, I contract an EC2 instance at 500 megabits because I know I can get 500 megabits from point one to point B. I might get better within the same hypervisor, but there's no guarantees. I'm struggling with the 25 gig. I think what is it? 25 gig from any point in the data center.
Yeah.
Even with so from the whether I'm consuming bare metal or a virtual machine, you guys are guaranteeing 25 gig from one OS to another OS within the same data center.
Yeah, so for a bare metal machine, which actually has 25 gig, yeah, that's essentially what we are doing, yeah. And it does require a non-over-subscribed network, so literally from any point to any other point, barring if a machine essentially gets more than 25 gig to it, obviously something is going to get thrown off. That's the reality of it. In-cast problem, essentially. But beyond that, it's designed so that any point can talk to any other point with 25 gig.
So that means that like a single virtualization host that's running multiple VMs, those VMs are being presented with the 25 gig link, or they're
Not
being
all
presented
VMs have 25 gig. So
Okay.
I think our product page has the network bandwidth for VMs, how much they have. They essentially have a slice of it. Right?
So you're guaranteeing that the aggregate of all those VMs is going to be 25 gig,
Yeah.
and that's how you get the non-blocking.
Exactly.
Was there something in your research or development that indicated that a non-blocking network was essential to performance, or that it was causing issues in other public clouds that you were solving for?
Yeah, so I think, I mean, it's essentially the level of O subscription, right? We do know that, I think from past experience, I can say that O subscription, for example, at a rack level, has severe implications, right? You can move the O subscription from one place to another, and the problems change. So the way I look at it is, yes, you can oversubscribe. In fact, I will actually talk about where we actually oversubscribe. We do have oversubscription, particularly when the data goes outside the data center. We do have oversubscription there. Internet has oversubscription. So there are points in the network where there is oversubscription. But within the data center, we do believe that in order to give a strong SLAs and essentially the no noisy neighbor experience, if you will, we really needed the non-blocking network.
So can you talk about the scale of a single data center and how it relates to a region? Are there multiple data centers within a region, or is it a region is equal to a data center?
Yeah, we definitely have multiple data centers in a region. So we have, typically we have 3 availability domains in a region, and each availability domain has at least 1 data center for obvious reasons. We may also have, more data centers as we expand capacity, and if you run out of capacity, physically speaking, in the building, or from a networking perspective, we'll build another one very close to that and connect them up.
So the ability to guarantee network performance is based on the concept of a data center. So within a building, you may have multiple data centers in theory within a single building. A boundary is networking, another boundary
Physical.
is physical.
Yeah, and sometimes it's power. All right, cool. So to sum it up, I think we fundamentally believe, we need a ground-up architecture from an infrastructure perspective in order to deliver the value that we want to provide to the enterprise customers. And we believe we have that platform from an architecture standpoint. We are starting to, see the dividends coming out of it recently in the form of SLAs, things like that. We'll have more. Cool. Questions? Anything else I can go deeper into?
So this can we talk a little bit more about the networking from a virtual network to a physical network on a host? You guys are giving us a physical network. So there's a back-end management piece of that you guys can manage and provision the physical host, carve out virtual networks for the end user. How do you guys make that a multi-tenant network when you're allowing us to do something as complex as layer 2 from one box to another box? I can't do layer 2 in other clouds. One of the complexities of that is being able to carve up a physical network, virtual network into layer 2 domains and keep everything running at scale. How did you guys solve that problem to allow layer 2?
Yeah, so I think layer 2 is specifically referring to layer 2 networking?
Yes.
Yeah, so layer 2 networking does have scale challenges. It doesn't necessarily have performance challenges. I think the way I look at it is, purely from a network design perspective, we can divvy the problem up into data plane operations and control plane operations. So if you look at it from L2 networking, most of the complexity lies in what I would call as control planes. So for example, let's say there's a MAC, there's an ARP that's propagated, and that has to go across a whole bunch of nodes. And let's say that the nodes are all over the place. In a physical network, it's probably within a rack, but here it's all over the place. There is a control plane problem there. There's a scale out problem. However, once you actually learn where the IP addresses are and the MAC addresses are, it's not a huge challenge. We can then figure out how to populate the data plane components appropriately, and as long as they have the right design, it'll perform very well. So from a performance standpoint, it's not a huge deal. From a scale standpoint, it is a challenge. The way we think about this is, I think we want to put boundaries within the problems. If there is a scale problem, we want to limit that to some boundary. So subnets cannot be 1,000,000 nodes. We want to limit the subnet to some small number, and we know that within the limit, we can figure out how to manage the blast radius. If there's a broadcast, we know how to do that. We can design around that. So that's essentially how we want to do that. But at the same time, we don't want to limit the entire network. So as a good example, we acquired a company called Revolver, which had L2 virtualization technology, and we are working very closely to move some of the technology as close as possible to the OCI platform itself. And part of that, if you have a network which is pretty much unlimited, and it can be in a region, it can be anywhere, but you can have a subnet within that, which is maybe a little bit more constrained, and within that you have all the capabilities. So and that doesn't mean there's no connectivity across them. There's still entirely private connectivity from this set of hosts within a subnet to anything else in the network. But at the same time, the L2 functionality, like the IP migration or broadcast domain, things like that, will be limited to that.
And when we're from a physical and logical network perspective, might have to whiteboard this for me, but you have 2 ports on a.
Thank you.
Oh, okay. Yeah.
Did you say the word whiteboard?
Yeah, evidently that was the magic word.
We have voice control.
Yeah, that was really
Okay.
So within my own data center, and I'm the only tenant within my own data center, I can have layer 2 between 2 switch ports, and there's no problems. However, if I'm sharing a physical switch between multiple customers, what techniques are you guys using to limit the layer 2 to just that customer's virtual network?
Yeah, so we essentially have our own logic that pretty much does what you're talking about. So we could have, let's say, I'll use a couple of different colors. Let's say we have 2 different VMs that are sitting, next to each other, right? So this is like one giant bare metal machine, and you have a VM1 which belongs to the blue customer, and we have a VM2 that belongs to another customer, right? And we have a similar big box here, and that essentially has a VM3, which is a blue customer, and a VM4. So the way we decide that, and it can be anywhere in the region, it doesn't matter. The way we deal with this is the packets that are coming out of this, and the packets that are coming out of this are essentially subject to a whole bunch of processing that's very custom to us. And there we essentially know, hey, these packets are coming from the blue VM, right? And if they're essentially trying to do a broadcast, let's say, we know that it's not supposed to go to the black VMs. It's only supposed to go to the VM3, which is the blue VM. So we make the decision in the logic in our network to essentially send the packets. The broadcast packets are then limited to essentially
That
small
whatever that.
machines, whatever that's allowed to communicate with that.
So 2 questions. First, is that what you guys are calling off-box networking?
Yeah, it is a combination of what I'm calling as off-box networking, as well as some of what I'm calling as physical networking. It's a combination of those 2.
So how does a physical host, so let's say that blue customer has a physical blue host. How does the physical blue host, well, he has a full physical host. How do you guys have the 3 different hosts, VM1, VM3, and physical host 1 communicate? So I have,
like
let's say, an
physical
Oracle. I have an instance of physical bare metal Oracle running on physical host.
Got it.
Imagine you
Okay,
just
so this
add
is
like
like a
the
database
VXLAN tag
node.
at the switch side.
So the problem with like adding VXLAN tagging, large cloud providers usually don't do it because VXLAN doesn't scale to what they need to do, and whatever they're doing in the off box perspective breaks. That's why you don't see layer 2 often
Yeah.
in public cloud providers, and that's the part that is curious.
Yeah.
Because I want to know where's the limitation that on your average customer do they have a problem with scale for their layer 2 domains inside of your data center, or you guys haven't had a customer that had that big of a problem that's caused you problems or the customer problems?
Yeah, I don't think we have seen a customer wanting like 1 million hosts in one subnet, for example, which is the L2 broadcast domain. So customers have generally been happy with that.
So
For
it's not necessarily the customer, because you end up running into practical problems of like cam table. So if your data center itself has 1 million devices, whether they're virtual, physical, whatever, and they're doing layer 2, that's a lot of processing to filter out who needs to go where. So at some point, this breaks at scale, and then you're also giving me a non-blocking 25 gig network at the host level. So it seems like I'm having my cake, I'm eating it, and I'm not getting fat. So there's somewhere there's limitations. I'm not a smart enough networking person to know where those limitations are, and I'm poking as far as I can go.
Sure. Let's see. Let me actually take you through a little bit of the journey here. So, you ask, hey, let's say there's a database node that's essentially talking to the blue guys. The mechanism, since it's outside the box and it has nothing to do with the box itself, it actually follows the same mechanism. It's no different, literally no different than what a VMs use versus VMs use. So that part is, it's fine. The logic that sits here that essentially cuts across all this, right? That's the logic that's key to us. And from a L2 perspective, yes, there's related limits. However, in terms of pure forwarding, we do have to deal with scale, and we are scaled to deal with millions of these essentially VMs popping up all over the place, and we will be able to deal with that. There are a variety of techniques as sometimes you essentially have. I'll just use the physical router analogy. We're not necessarily using the same thing, but physical router essentially have you may have a fib and a rib, for example, and the fib is essentially like the tiny little hardware table, and it's fairly limited, and then the rib might have a lot more, and if there's packets that don't match into the fib, the rib will essentially kick in and feed that in. We can also have a tiered, what I would call as a rib, where you can have a central service somewhere else, which is like a control plane service that we run, and we can essentially tier that off. And in the control plane service, it's like any other server, so it's pretty much unlimited memory capacity. So we can deal with the scale. So it's I think at some level, even in physical routers, we have a little bit of a caching mechanism, and I think in order to deal with cloud scale, we would naturally extend that mechanism using our own mechanism.
Okay.
Are you, just to pick up on a point you made, are you stretching the layer 2 domain between those availability domains within the same region?
Yeah, so that's a good question. So we do, in the sense that we do allow customers to go across availability domains. It is in the L2 domain today. There are two different answers today. If the OCI, if you go to the OCI, there's a notion of subnet that's actually within an AD today. However, if you go to Revelo, you can essentially have a bunch of lift and shift VMs, if you will. There, you can have a L2 domain that actually spans. And you have ways to connect them with, a database node, for example, that's running natively on OCI. And like I said, I think we are working, towards integrating that stack as closely as possible with OCI. And yeah, we essentially, it's the same technique. At the end of the day, from an architecture standpoint, it's the same bag of tricks that we play, independent of the layer.
So is that sort of a roadmap thing to integrate the Revelo piece closely enough that you would be able to offer those kind of things across
Yeah,
the
so I
entire
think
region?
if you look at the history, I think when Revelo came on, it was essentially like a layer on top. We started integrating. One of the things we already launched is a hypervisor integration, where we run the HVX hypervisor. It's a modified form of hypervisor that essentially supports many kinds of legacy operating systems, and we are natively running that on top of OCI bare metal. And we did that and it actually delivered substantially better performance than it did on top of VM. So yeah, we are iteratively working towards integrating the technology closer. Any other questions? Cool.
Is that where you're getting the value add with the Revelo piece, where you drop that into the hypervisor? Because Revelo, the original play for Revelo was it was optimized as a hypervisor to run on top of hypervisors, and that kind of goes away when you go, hey, we can install it on bare metal.
Yeah, I think that was when you in a world where the cloud providers don't have a bare metal, that is the only option. To me, I think the key value proposition of Revelo comes in the form of support for legacy operating systems and the things that don't necessarily have the latest drivers, things like that. That is the key value proposition. How do we get that in conjunction with better performance or improving performance? That's essentially where the tight integration of the hypervisor plays a role.
I guess the question is, if I'm going to lift and shift and I'm going to bring a VM from on-prem, why would I decide to put it on top of HVX running on bare metal as opposed to just putting it in Oracle Cloud?
Yeah, so today I think it's essentially...
Because you almost got two different VM options for me. Like, I either place it on Revelo running on, or I place it just in OCI. How do you differentiate between the two?
Yeah, I think that today the main difference is that Revelo has a bunch of lift and shift. It supports certain operating system functionality, legacy operating system functionality that our native VMs don't necessarily support. That said, like I said, we are working to integrate more and more of that. So I think our first step was essentially to say, hey, look, there's a Revelo stack, and how do we actually get the best performance and the best integration from a networking standpoint? So we essentially dropped the HVX on top of bare metal, and we actually saw a substantial performance improvement. I think the goal would be to iterate further in terms of presentation. Functionality-wise, customers today can essentially have a VM on HVX and essentially talk to a DBAS, for example. So they already can do that. So network connectivity-wise, it's already there. Yeah, that's essentially it.
So can you talk to us a little bit about the combination of use cases where people take bare metal services? There's stuff in my data center that I need to lift and shift it, but there's features in Oracle's cloud outside of my ability to lift and shift the workload, aka a colo, that enables me to have cloud services right next to that service. So one of the, when I hear VMware talking about AWS, VMware Cloud on AWS is the ability to take legacy workloads, put it close to the AWS services that we love. What's the story for the services that I can take my legacy applications that I need to refactor, put them in Oracle's cloud, and now there's this goodness next to those workloads? What's the goodness? Like, what? I think when we were here for the Revelo day, you guys called it move and improve. Where's the improve? What am I getting outside of the ability to outsource my legacy workload in a cloud data center?
Yeah, so I think the way, I'm sure the perspective will be different with different people. The way I look at it is, customers don't have just one type of workload. They have some legacy stuff, but in almost all cases, every customer is looking at, how do we, maybe for newer projects, they might want like container-based deployments, or other types of more cloud native stuff. How do I essentially have, if you're essentially in an on-prem data center, and that's maybe because there's a bunch of legacy stuff, it may also get in the way of essentially, even for newer projects, it'll be harder to adopt newer stuff. So the way I look at it is the move and improve is move the pieces that you have no chance of doing anything else with. And then for the newer stuff, I think there's a substantial opportunity to adopt newer things, containers or other cloud native services, whatever you want. And I think that, to me, I think a big part of that is networking. They all need to connect to the same network stack, right? So like whether you have a container in Oracle Container Service, and you have a Revelo VM, which is a very old legacy VM, or a legacy operating system that may be running bare metal, or an app that's running on bare metal, they all should be able to talk to each other. And
I think that's
easy.
what we have.
I mean, if I could interject just real quick, I think you're being very kind of theoretical with that part of the conversation. There are going to be apps that will have kind of cloud native type apps that may need to go back to some sort of legacy workload. That will exist. That does exist today. I don't think that's necessarily the norm, though. So to kind of paint the broad brush of saying, oh, well, this is needed. It might be needed for very specific use cases, but not broadly today. So I think it's important that you kind of characterize what it is you're offering and what the value proposition is. Because quite frankly, I mean, I've sat in a number of briefings with Amazon and talking about VMware, and I'm hearing the same things here about putting legacy workloads and VM-based workloads right next to cloud-native workloads. And unless you're going to bring those two together, those two have communications between those applications, the value is not there.
As a matter of fact, I think one of the biggest use cases that we have seen is essentially around database service, right? Obviously, for obvious reasons, Oracle database is pretty popular. They really do want to, you're correct. There may be other workloads where there are other types of patterns, if you will. One of the things that we have definitely seen is essentially, hey, I have the database and I want to move that to a database service, and Oracle clearly has, the Oracle database service is, pretty important for those customers. But then I have the other stuff that needs to talk to the database. What do I do about them?
Right.
So that has come up quite a bit.
And that
But,
makes sense. That
yeah.
makes sense.
Yep.
Yeah.
So would you talk about like a workflow or a story of a customer picking up an application in their Oracle database, putting it in here, and then the improved part of that is sort of moving the Oracle database into one of your like database services within the Oracle cloud, so they're not having to manage the VM for that piece, and then gradually kind of gaining the improvements that way.
Are you looking? If you're looking for a specific customer example, is there anything?
Yeah. I mean, so I think the database is probably the most common use case, right? Like, and again, I think these customers we're talking to, in some ways, there's a hardware refresh component to it, right? If they're able to move this environment that's typically on-prem is 4 or 5 years old hardware, right? Magnetic based, all that kind of stuff, and they're able to move into this infrastructure, either completely without change, let's say in a Revelo, or they start to use database services, one incremental step, or they start using object storage as a backup, another incremental step. That's a little bit of what we mean by the move and improve, right?
And that stuff you showed in the networking, that is tightly coupled with the networking where this legacy stuff would be moved, and
Yeah.
that you've got that integration
Yeah.
to kind of hit those things very easily.
Yeah.
So what those talk to us a little bit about those public services and the networking between the legacy. I have my data center architecture, that application. I have private IP addressing on that. Do you guys provide private networking to those public services you offer, like the Oracle database service, the Oracle container service, et cetera? Can I get private networking for all of those multi-tenant services that you offer in my private
Yep.
instances VMs that I've moved over?
Yes.
I think the larger question for me is, I get the idea behind lift and shift or move and improve. I like a lot better. Why would I pick Oracle Cloud over the other public clouds that exist today? Is there some whiz-bang thing, some amazing feature set? What's the value add that I get that I can't get anywhere else? Because a lot of the IaaS stuff is fairly commodity at this point. There's not a lot of differentiation there. So where's my big, I want to go this way, I want to go Oracle Cloud?
Sure, I'll start with my perspective. Feel free to jump in. To me, I think a big attraction has been the Oracle assets, the databases and the SaaS applications and the SaaS services. That has been a big pivot. In the infrastructure side, like I said, I think our biggest things have been around bare metal, the fact that we have SLAs and we have, we recently launched a bunch of HPC products. So I think there's a bunch of key attractors in the infrastructure space. But what I've seen is that I think a huge part of that is customers come in because they love database or one of the SaaS services, and we need to be able to it's not as they don't want to just move database. It doesn't work at all. So a key part of what the value we provide is essentially how do we help them move everything else, whether it's like Oracle stack, as well as other stack that they want to install and run.
You provide a migration service on top of Oracle Cloud to help people get into that.
Do you want to take that?
Yeah, so we certainly have migration tools for nearly the whole Oracle on-prem application portfolio. But I think the big thing is it's a combination of technology and people at the end of the day, right, and process. So we have the tools, we have an attractive database and infrastructure service, but certainly the ecosystem is very important, right? So if they trust us or they trust a particular service provider or MSP that's going to come along for the ride and bring that infrastructure into the cloud, that's really important too, right? So it's definitely not just about technology. I think you're going to hear some similar things, but having the ecosystem and having then the, as Pradeep said, sort of that reliability component, right? So some of the other presenters are going to talk about some of the unique technology that we have or technology that other people haven't implemented when it comes to database, when it comes to the actual infrastructure. Here I just wanted to set the grounding and the context around the architecture. But anyway, at the end of the day, it's a combination. We do have some technology that plays a part in terms of migration, in terms of attractive services they can run on, but also working with that ecosystem and those customers to help them move the people and process into the environment too.
Can we talk a little bit about support at the bare metal perspective? Since I can bring my bare metal workloads into Oracle, and we talked about, Scott has asked about hardware, which is a critical component to that. Do you guys have relationships with VMware, Microsoft, Red Hat, etc.? So when I'm taking my Hyper-V and running it directly on your bare metal, something breaks, and they say, oh, are the latest drivers installed? Where's that relationship from a support perspective?
You want to take that?
Yeah, so some of it is going to be the provider of the operating system, right? So we do have these license agreements where you can bring your own license, for example, with Microsoft. And certainly when you think about hardware, there are some interesting constraints or challenges when it comes to providing bare metal, right? So one of the things that we are experiencing is people bringing their workloads and staying on a single server, right? Versus ephemeral and moving the compute around. So that sort of presents a different set of challenges. So one of the things we've done around that is basically provide interfaces so that you can, for example, get a drive replaced, right, within that infrastructure. So some of these things start to look a little bit like somebody's own data center or somebody's on-prem data center, because these customers and the way they're using the infrastructure is different, right? So from a software perspective, yes, we work with most of the major vendors in terms of providing support and working with them on cooperative support around like an operating system. At the infrastructure level, we do handle the support, and then we have some interesting differences once you get down into things like bare metal.
Sorry, did you just say that I can request a drive being replaced in my bare metal, in my cloud bare metal server?
Yeah. So essentially, we provide a way to do that, right? If you're going to be running on an infrastructure for a really long time, as I said, you start to run into potential challenges with you need to replace actual drives within a server. So by providing an interface, so you know, right, that something's going on and that it needs to be replaced, those are things we're providing and working on additional support for.
Don't you just do that? Isn't
Yeah,
that what
but
I'm buying?
if I've bought a bare metal server and I'm running Windows on it,
Right.
I'm taking responsibility for the OS up. They can't just go, if I say, you know what, I want a bare metal server RAID 0, they can't go and pull the drive and replace the drive. My OS is going to come down. There has to be some type of coordination between.
It actually depends on the architecture that the provider's using for bare metal, because some of them, they can replace drives. Not all of them can, though. So is it that just to clarify, kind of to Keith's point, and maybe to address Justin's question, is it that when you have a bare metal service, is it that you're essentially allocating boxes, devices to a given customer? And so you're going down to the most fundamental level of bare metal? I mean, literally?
Yes.
Okay.
Yeah, so we have no software on those boxes.
Not at all?
Yep.
Okay. So if that's the case, then
I'm renting a server in
essentially
in a colo.
that's all you're doing.
renting
It's
a
a
server.
clever way. It's a creative way of financing. You're financing hardware through.
And I can raise a support ticket to have an operator go and swap a drive for me.
Correct.
Yep. Which is not cloud, but
It's not a colo either.
Well, it is.
yeah, it is.
Yeah, it is.
It's just
But it's not your hardware.
Yeah,
No,
but this is exactly what
functionally it is. Yeah.
this is exactly what co-location providers have been doing for years now. They've offered this as a service where they'll essentially all it really is. I mean, correct me if I'm wrong. All it really is it's a financing vehicle for financing infrastructure. You're shaking your head in the back. Tell me why it isn't. You need a microphone.
Sorry, I work with a lot of customers, and I'm up next, and I'm sort of itching to go, and we're running over a little bit. But the off-box networking virtualization there between the bare metal machines and the virtual machines,
Yeah.
that's what your colo doesn't have.
Yeah, but that's beyond the box itself, right?
Colo doesn't have this ability to move seamlessly between bare metals and VMs.
I think you're splitting hairs a little bit. I'm talking about the server itself, the server and storage subsystem. Okay, that then ties into some network infrastructure. So I'm taking the network infrastructure out because I realize that's a differentiator for you. But when you're talking about the server itself, because we were talking about drives, the server storage infrastructure, that in itself is no different than if I were providing the
Yeah.
hardware.
All practical
Yeah.
purposes, not. I think if you're defining what a colo is, I think one way to look at it is like, hey, I have the whole machine. But the other way I would define that is, how quickly can I get the machine if I want to, right? I think typically in a colo provider, it takes a while.
No.
Right?
No, I think you're confused. Again, I think you're confusing the matter. Co-location is just it's someone else's data center. But
Sure.
they have services beyond that where you can lease, essentially you're leasing hardware from them and then riding on whatever their network infrastructure is. Okay? That's essentially what you're doing. But you have a very unique way of managing that network piece of it. The server piece is really
As well
what
as
I do.
allocation. So like, API call allocates the server pretty much
Yeah.
very fast.
Other
That's
providers do that.
Packet.net does the same thing.
Yeah.
Yeah.
I think-
Sorry, with this hard disk example, you've done all that. You've got the API, you've got the networking piece, the server's there. How do you find out that a hard disk has failed? And why have I got to raise a ticket to have a hard disk replaced? Why don't I just get this downtime going to occur, there's a service occurring. Do I have to monitor all that? Do I need out-of-band access to the hardware to monitor those pieces as well?
I think from a software perspective, I think it's no different than if you had a machine with 16 NVMe drives and you had some replication software that's running and MongoDB, whatever it is. I think it's essentially the same thing. I think part of it is even if you're capable of it, I don't know if you'd want to actually remove drives.
No, I wouldn't.
Without
I just-
telling, without actually customers initiate in some fashion.
So I guess the
for a
question
variety
is,
of reasons.
at what point does Oracle software to manage the infrastructure get in the way of me getting bare metal? If I want bare metal,
Yeah.
but I don't, there's a trade-off somewhere. If I want bare metal and I want the most support for my workload as possible, there's a sacrifice, which means I don't want any abstraction from Oracle software. I just want bare metal. If that's a desire, this is for you. If you want, invisible, you get virtual bare metal, and you want virtual replacement of drives, then there's a layer between the OS and that virtual bare metal. I think, which trade-off do you want?
It's feeling a little bit like this is the cloud for people who don't actually want cloud.
I think that's an accurate portrayal. This is the cloud.
I felt like that about when I've seen Oracle's cloud before. Exactly that. It's basically I want to run Oracle somewhere else.
Yeah, which is not wrong, but it's like
Do you
not
have
wrong.
a slide that
There's
shows the
more.
different versions of product or offering that you have in the portfolio?
Yeah.
Do you have one slide that shows kind of the bare metal piece, and then shows the shared infrastructure piece, and then shows?
So I don't have that slide handy of every single offering. I mean, it's absolutely on our website. But just to kind of clarify, right? So on the compute side, we've got a range of compute offerings from pure VMs, single OCPU or 2 vCPUs, all the way up to 24. We offer local storage on those VMs, or they can use remote block storage. Okay. On the bare metal side, same kind of deal. We have ones that have local storage. We also have ones that use remote block storage. Okay, so that's again where you have that flexibility, where if you want the storage local to that machine and you want that type of latency profile and you want control over that whole environment, you've got it, right? That's where no Oracle software is running on that machine, right? You have complete control. Or you can start to, again, make that trade-off, right? Where you want the compute resources and you want the storage resources in a more managed way, you can do that too, right?
And this is API callable.
all,
as well,
all
so
of
I can
it.
say.
So again,
Yeah,
not to
okay.
debate semantics.
No. Yeah.
Yeah, it's all API callable. You can provision many of them at the same time, right? When we get into the HPC part, you'll see that these customers are provisioning many dozens of these machines at the same time to run a workload, right?
And unlike having it myself, I can turn them on, run a thing,
That's
and then
right.
turn them all off, all
Yes.
through
Be billed
APIs.
by
and
the
have it
hour,
programmed. Yeah.
right?
Yeah.
So again, I think why this may be hard, Tim, is we are doing things that are a mix, right, of some of these definitions, right, where we have a range of things. When it comes to the different, in each of these buckets, there's some of the things that are in other clouds and are obvious, right? On the storage side, you have all the things you would expect. There's block storage, there's file storage, there's object storage, there's archive storage, as well as that local storage. On the database side, which Sean will cover, again, a range of database shapes. Okay, so you can either have it in a VM, you can have it on bare metal, you can have it in an Exadata type of shape, which has integrated compute and storage. Okay, so in reality, the core offerings are exactly what are on this slide, but there's variations of the compute, the storage, the database offerings. Does that make sense? And I think your point, well taken. There's a financing kind of how do you want to pay for the thing, right? There's a range of options there too.
Right.
There's certainly the pay per use on demand model, right? We offer something called universal credits that let people essentially buy a pool of credits that they can use for any platform or IaaS service, right? So they commit to a certain total every month, and they can drain that total however they choose, which gives them flexibility across all these resources, across workloads, from a month-to-month kind of basis, right? So There's lots of different layers here, right? Absolutely agreed. There's a financing mechanism and how people consume it in terms of dollars. There's a range of offerings in terms of the actual resources themselves and how people consume those, and what the responsibility matrix is in terms of how much do they have to monitor and keep track of it versus letting the provider do more of the heavy lifting. If that makes sense. Does that help, Justin?
Yeah, I think it does. Yeah.
Okay. And again, you have this range, right? You have this range of use cases. And I think this is why the enterprise is interesting and complex. You have applications that they literally don't want to touch, right? Zero re-architecture, but they don't want to host the hardware anymore, and they don't want to go to a colo, and they want to move. Great. There's an opportunity to handle that workload. There's some workloads where, well, there's an opportunity, there's some budget to go and improve it in some way, right? Extend it, add some new capabilities, at least shift the database to a newer version, right? Where they can take advantage of additional capabilities in the database layer. Great. That may be a good play too. And then there's the ones where there's a complete rewrite, right? I think that's why enterprises, again, are interesting. They're going to have all those things, right? Some of their lines of business, SaaS, great, no problem. We can move that work. Very happy to accept it. We don't want to customize software any longer. Great, right? So the bigger the customer, the more likely they're going to actually want all these things in order to satisfy them. And they'd like to also not use 10 different providers, right, to provide this infrastructure. They'd like to centralize on a handful. So that's sort of our play.